Hi, and thank you. Welcome to my session here. So today we're going to talk about anti-phishing mechanism. Right. So in the PCI DSS specification, it mentions about what you're supposed to do anti-phishing controls, and it mentions as a combination of DMARC, SPF, or DKIM, and basically it stops there. So normally you would have a question of like what these are, how you use it, and probably most importantly, how is everybody else using it. So just a quick question, if you raise of hands, how many of you have actually started doing anti-phishing mechanism? Okay, we have two. Great. Good, then I'll go slower on this one then. Right. So in this session, I'm going to talk about how you actually develop the anti-phishing controls. The three things that were mentioned, SPF, DKIM, and DMARC. So normally if you go to a restaurant and then you ask them how do you order something, and the waitress will tell you, order one main and a side and choose two sides or something. For here, what you do is actually you pick one of two sides, which is either SPF or DKIM, and then you pick the main, which is DMARC. How this works is that SPF and DKIM are basically a mechanism to detect if your email is like a suspicious email. And then it doesn't do anything. It just tells you whether yes, it's suspicious or no, it's not suspicious. And then DMARC is the one that actually comes in to actually do the action. So you would, based on the policies, you could say that if the SPF and DKIM is suspicious, then you do something. And the action in that case would be either you do nothing, which is none, or you quarantine it, or you reject the email altogether. And so it's sort of like if you look at it in a sequence where it flows down, so people normally start with SPF, which is the simplest, and then DKIM, optional, but it's a bit more complicated, and then they do a DMARC. And from the DMARC, they go to a none, quarantine, and reject. Based on that, you can see this is the progress of the PCI industry today. This is a survey done on all the PCI organizations, about 2,000 PCI organizations, spanning from PCI America, PCI Europe, as well as PCI Asia. So you can see starting from the left, no policy, so that's about 15%. So 15% of the PCI-related organizations have not reached a stage of doing DMARC. They are still in the process of doing DKIM or SPF. And then the next one, P equals none. So that's a policy is none. So most likely they actually have one or two in place. They either have SPF or DKIM in place, but they are not very confident of it yet. So they don't really want to do any blocking action, which will disrupt business. So in that case, I set the action to none. So even if you detect that something is suspicious, you don't do anything with it. So that's a none. Then normally at this stage also, they're using this to gather data. So they get like aggregate report or to find out the statistics, how many false reports there are, what they need to adjust and everything, what they've forgotten to include inside their configuration. Once they're more confident with that, they'll go into the quarantine stage, which means when they see a suspicious email, they'll actually put it, for example, into a junk mail folder or something, where the user can still evaluate for themselves whether this is actually good or bad, because you never know what is actually correct or incorrect sometimes. And then the next stage, once they actually get this really in control, they actually enter the rejection stage. So they're very confident in the sense that when they see something that is actually rejected, marked as failed by DKIM or SPF, they will reject this email straight away. So what you're going to see next, so I know the title basically says best practices, and it says like from Northern, from Europe and everything, but in actual fact, we're actually covering global information here. So this 3,000 configuration for SPF is based on 2,000 PCI-related organizations around the world. Like I said, it's from PCI Americas, Europe, and Asia as well. So what you'll be seeing after this is basically what everybody is doing. So what your neighbor is doing, what everybody else is doing. And with that, you can compare to see what you're doing is like on par with what everybody is doing, or is it like really off course in that sense. DKIM has a bit more. DKIM has 8,000 configurations because DKIM is a bit more complicated, to say the least. In DKIM, you can actually set different configuration for the same organization, in between the same organizations. So they can switch keys, they can switch the things, so it gets very, very complicated. And in this case, it was a bit difficult to get the PCI organizations on this. So these 8,000 configurations is mostly based on finance-related organizations in the Baltics and Scandinavia. DMARC is about the same as SPF in the sense that their configurations are all published on the DNS, the domain name server on the internet. So it is based on the 2,000 configurations. It doesn't have 3,000 because in SPF, they have this thing called include, which is sort of like you would say like a redirect or something that would actually include another configuration from another server. So that's why it expands from 2,000 organization can have 3,000. 2,000 organization can have 3,000 configurations. So the first thing I'll go into is SPF. So there's a standard policy framework. And if you want like accurate details about this, just Google or use your favorite search engine to find RFC 7208. That's about a 100-page document that basically describes everything that you ever wanted to know about SPF. There's one curious thing that usually nobody mentions about SPF is that it doesn't always work. So that's the one shocking thing. And why does it not work? Because of this thing called SPF temporary error. And what happens is SPF is very dependent on the DNS, the domain name server. So it needs to go there to check, to compare the IP address, the referrals and everything else. The more you use the DNS, or the more complicated queries you make, the slower it takes. And a DNS server is just not designed to handle this kind of queries. It was, I think, originally designed for like the web browsers where you just pick the address and then it continues there. But here it's like you just keep going non-stop for every single email. And every single email can have multiple ones of them. So pity the DNS in that sense. And in the specification, it actually says a 20 seconds timeout. If it hits 20 seconds, it gets a temporary error. And what happens is that temporary error depends on how you configure it. It could be that when your server hits a temporary error, it just ignores the thing and says, I'm not even going to check it. I'm just going to say this is okay, even if it's suspicious, because I ran out of time to check this and I just can't check it. So I'm just going to let it go. The other thing with temporary error is that in the specification it says, if you encounter temporary error multiple times, it will automatically upgrade to permanent error, which means it will never ever check this again. So even if you set this up and you're PCI compliant and everything, this SPF is not going to work on you because your SPF has been listed in a temporary error and just ignore this. Now the chart on the right, yes, it looks very complicated. This is in the time and era of artificial intelligence, so I have to explain this chart for you. This is what we call a correlation chart. So what it does is that it takes all the configurations that you see and then it goes through a pattern analysis to find what's in common. So for example, if you say like, the sky is getting dark, then you kind of think it's going to rain. So that's like a correlation. So it may or may not happen, but there's a good chance that it's going to rain. So that works that way. The bar with the highest at the top, so those are the most likely to happen. And the ones, as it goes down, is less likely to happen. The maximum point here is basically 0 to 1. 1 means like 100% that it will occur. So here you have about 10%. So if you look at the top right chart, that one, the first thing that is most commonly associated with temporary error is this thing called macro argument domain. It's one of the settings in SPF itself. It's kind of like a powerful feature. It's sort of like in Excel, you can use a formula, you can replace and something with a variable and everything. It's fun to play with, but it's computationally expensive on the servers. And one thing that we discover is like it's seldom used in the PCI community. It's used elsewhere, but not within the PCI community. We see very little use of it. And every time you see it being used, it ends up with a temporary error. So it's not a good idea. The other things is the last one is cross DNS queries. So that's the one that I was talking about. Anything that uses the domain name server is likely to encounter error. I'll go into this on the next slide. And just for your trivia thing, The opposite is at the bottom. What are the SPFs that causes the least errors? And those are those that don't use DNS. You can see they're using IPv4 addresses. So they skip the DNS server altogether. And just for curiosity, I won't talk too much about this one. In this one itself, where the email servers use just IP4 addresses, there's also a certain limitations in the sense that you use just probably at most 256 IPs in your range that you put there. You don't put in like 256,000 IP addresses in that. So there's also a certain consideration when you're using that. But for most of us, I mean, we're not able to skip the DNS. I mean, DNS makes life easier to manage for the whole organization. So one thing to look at is like, fine, we are forced to use DNS, but how can we use it in a smart manner, in a wise manner that we don't create unreasonable loads? So what you can see here is what the majority of people are doing. They limit themselves to one include, and they use a soft fail, and you see that they don't use the macros. So if you see at the bottom, the worst case scenarios is that there are some PCI organizations that use 7 includes. So that's probably not a very good idea. And you can understand for some of them it's probably not much of a choice in the sense they are either subsidiaries of a giant company, so they are forced to include their main group holdings, companies and everything. Or some of them, they were actually bought over by other companies, they rename and everything. One of the dangers is that in this, the SPFs that has lots of includes, sometimes these includes actually are invalid entries because they just keep adding the things and they don't filter it, they don't remove it. So some of the IPs are not even valid, or some of the IPs are completely, the DNS has changed as well. So that's just as crazy. The longer the includes, the more chances they'll fail. So that's one thing that should keep in mind. If you have a lot, try to trim it down if it's possible. So a few key points about SPF. One of the things that most commonly I come across is actually typos. Surprisingly, but true. Because today SPF is actually created in a text form and it's added as a text entry in the DNS server, in the domain server. And most of the time, people managing the email, they don't manage the DNS server. So you basically have to go to another team to get this done. And even if you use some cloud service that have some wizards and everything to help you compose the SPF and everything, in the end, they create you one text string and you're still supposed to copy and paste it into your DNS server. And what we've seen a lot of the times is a lot of typographical mistakes. So commas, equals, semicolon. So a lot of mistakes that just could not be understood by the server itself. There's also a lot of parameters and values. In SPF, there's the difference between mechanisms and modifiers. So you need to use them in conjunction. Sometimes you can't use one without the other. They're kind of dependent on each other. So it's, if you miss one of them or you mix up one of them, then that mechanism doesn't work anymore. DNS usage consideration, that's what I mentioned multiple times. And of course, macros is something like not commonly used and probably not recommended to use. The next thing is DKIM. So just now, in SPF, you basically create a whitelist of who can send emails on behalf of your organization. Now, what happens today is that the mails are still sent in plain text. So you could just say, I'm sending it from some abc.com, and there's no way for you to verify that I am really sending from abc.com. You just have to take my word for it. So what they came up with is this thing called DKIM, domain keys. So these are actually signing keys. What happens is actually it signs your emails, the contents of the email, or the headers of your email, so that the recipient are able to verify the signature and make sure that the contents has not been modified or edited in that sense. And the most common form today is basically 1024-bit. So this is not PCI. This is more the finance industry. If you attended earlier sessions on quantum computer, this would be like a joke to you, because 1024-bit is not quantum safe. It can be broken by a quantum computer either tomorrow or this afternoon. But what's the impact? Well, this is not encryption. There's nothing secret in here. This is actually just a signing key. So you're just creating signatures, which means that even if a quantum computer breaks this thing, what it can do is that it can imitate your signature. It can pretend to be your company that's sending the email. That's the impact of it. And of course, the specifications recommendation is that you change it often. You don't leave this 1024-bit key for 10 years or something like that. So you change it often so that it's even if it's breakable, they can only use that vulnerability for a short period of time. So if you change it every month, then it means if it's broken, it can only be used a month before you come up with a new key. One interesting thing to take note is in this one that the majority of people, organizations are using, is the canonization is relaxed. So canonization is this thing where it checks the text and the headers, how you format it. So if you have extra spacing or extra line breaks or something like that, whether you are okay with it or you're not okay with it. In this case, most of the time it's relaxed. And the headers, so this is the number of headers like subject, mail, to, recipient, and everything. It's about 6. And the validity, signature validity, like I mentioned there, is about 1 week here. And the interesting thing to note is a lot of queries in the industry. Everybody's asking like, how can I improve the security? Because it is widely acknowledged that 1024-bit is actually very weak. So what is the next alternative? If you ask the AI chatbots out there, they'll actually tell you just to upgrade your key to RSA 2048. Okay? Well, some people do that, and this is what they do out there. But what the AI chatbots will fail to tell you is that the key size is not the only thing. There's actually a lot of other things to consider. So if you look at the differences here, the canonization now is actually simple. Simple is actually means, although it's not that simple, it just means that it's not relaxed, it's tighter. So it doesn't tolerate any modifications there. The headers are also increased, so there are 9 headers here. And you can see the headers on the left, this recommended in the specification, and then on the right is what people are actually using. And you notice there's quite a difference. Reply to and CC are actually not used in real life for some reason. That's the key points there. I'm running out of time, so I'm just going to skip ahead. Finally, DMARC. So this is your final stage. After you get all the other things done, in this final stage, you still have 3 levels. You have none, quarantine, and reject. None is, again, when you're not confident that you've filtered everything. So you're probably getting a lot of false positives here. And the idea here is basically you just want to test it to see how well you're doing before you start blocking emails and disrupting business. The next stage is quarantine. So here you see one of the top things is that it starts the report to self. The percentage is much less as well. If you see earlier on, the percentage is 90% to 100%. So you're not processing 100% of the emails, you only process 90%, 100%. But in quarantine, now because you're actually starting to do reportings and you're actually putting mails in junk mail, so you don't want to disrupt business, you don't want to create too many disruptions. So here you drop it down to 1, 10, and 5. And once you're really confident, you go to reject. And here you can see that the settings are also very much different. You can download this to find out more details. But the other thing I want to talk about in the last minute is the reports itself. So when you're actually doing the DMARC, there are 2 reports you send, aggregate and forensic reports. And there are 2 choices. One you can send to providers, or you can send to self. When you send to providers, in PCI Americas, they don't really care about this. This only happens in EU, in Europe for some reason. Asia, they don't care about this either. The important thing is that there are a lot of vendors out there, they're called DMARC providers. And what they do is they take care, they receive your reports, your aggregate reports, and your forensic reports. The important thing here that a lot of companies are asking and checking is like, are these companies EU companies or non-EU companies? And the other thing is, even if they're EU companies, are their servers in EU or not? If you think no one's bothering about this right now, take a look at Northern Europe. Countries like Greenland, Faroe, Iceland, Norway have started moving in this direction. So for them, it is important that they're using a reporting server that's located in the EU. And then of course there's like, if you don't want to concern you have all this, you can host it yourself. But when you host it yourself, take note there's a lot of changes you need to do. You cannot use the same setting as when you're sending a provider, because you're going to overload yourself and create the denial of service attack on yourself. So download this slide and you can see the difference in the settings, and compare that with your own and see what's the best way to adjust for it. So I hope you learned something from this. Thank you.